And next question is limit x tends to infinity, x raised to minus 4 by 3 by sine 1 by x. So if you take limit x tends to infinity, x raised to minus 4 by 3, so that is infinity raised to minus 4 by 3. 1 by infinity form, that will be 0. So again limit x tends to infinity, sine 1 by x. 1 by infinity is 0, so sine 0 is again 0. So it is in 0 by 0 form. So that will be equal to limit x tends to infinity. So we will get minus 4 by 3 into x raised to minus 7 by 3 varum. Then derivative sine 1 by x is cos 1 by x into minus 1 by x square. So this is by L'Hospital rule. So that will be equal to limit x tends to infinity minus 4 by 3 into so x square, okay, plus 4 by 3 vare minus sign under. X square will go to the numerator, so that will give you x raised to minus 1 by 3 vare, okay, by cos 1 by x. So this will be equal to, so limit x tends to infinity, x raised to minus 1 by 3, it will be 1 by x raised to 1 by 3, upon 1 by infinity will be 0, and cos 1 by 0, 1 by infinity 0, so cos 0 will be 1. So the value of the limit will be equal to 1. Now let us look at the indeterminate form of type infinity by infinity. So 0 by 0 form now when the numerator limit infinity, denominator limit infinity case infinity by infinity form. So the limit of the ratio f of x by g of x, in which the numerator has limit infinity and the denominator has limit infinity, is called an indeterminate form of type infinity by infinity. In problems ചെയ്യുന്ന കേസിൽ ന്യൂമറേറ്ററിന് ലിമിറ്റ് നമ്മൾ ഇൻഫിനിറ്റി എന്ന് പറയുമ്പോൾ അത് പ്ലസ് ഇൻഫിനിറ്റിയോ മൈനസ് ഇൻഫിനിറ്റിയോ ആവാം, അല്ലെങ്കിൽ അതിന്റെ പ്ലസോ മൈനസ് ഇൻഫിനിറ്റി ആവാം. ചിലപ്പോൾ ലിമിറ്റിന്റെ വാല്യൂ ഇൻഫിനിറ്റിക്കും മൈനസ് ഇൻഫിനിറ്റിക്കും ഇടയ്ക്ക് ഓസിലേറ്റ് ചെയ്യുന്ന പോലെ ആയിരിക്കാം വരുന്നത്. ഓക്കെ, സോ ഇറ്റ് ക്യാൻ ബി പ്ലസ് ഓർ minus infinity, limit of the numerator, അതുപോലെ limit of the denominator can also be plus or minus infinity. It is not mandatory that it is always plus infinity. So you can have a combination of plus or minus infinity. And so we will move on to the rule when you have in the form infinity by infinity. So again, f and g are differentiable functions on an open interval containing x equal to a, except possibly at x equal to a. So at x equal to a, function need not be defined, and that limit x tends to infinity, f of x is equal to x tends to a, f of x is infinity, and limit x tends to infinity, g of x is infinity. Then the L'Hospital rule states that if limit x tends to a, f dash by g dash exists, or if it is plus infinity or minus infinity, then limit x tends to a, f of x by g of x, that will be equal to limit x tends to a, f dash by g dash. And the statement is again true when you have limits of the form x tends to a plus, x tends to a minus, x tends to infinity, or x tends to minus infinity. So let us see a few problems using the L'Hospital rule for infinity by infinite form. So evaluate the following limits. So So first is limit x tends to plus infinity x by e raised to x. So when you take limit x tends to plus infinity x, so that is infinity, and limit x tends to plus infinity e raised to x is again e raised to infinity is infinity. So this is an infinity by infinity form. So by L'Hospital rule, so this will be limit x tends to plus infinity, take the derivative of numerator and denominator, so you will get 1 by e raised to x. So 1 by e raised to infinity in infinity, so you will get 1 by infinity. 1 by infinity is 0. So that is the value of the limit. Now let us take limit x tends to 0 plus ln x by cosec x. Again limit x tends to 0 plus ln x. Ln of 0, when you take ln of 0 goes to minus infinity. Okay, so here you have minus infinity, and limit x tends to 0 plus cosec x. So that is limit x tends to 0 plus cosec x എന്ന് പറഞ്ഞാൽ 1 by sin x. അപ്പോൾ 1 by 0, that will be infinity. So you have in the form minus infinity by numerator limit minus infinity വരും, denominator limit infinity. So that is in infinity by infinity form. Okay. So now upon taking the derivative, you will get, so limit of the numerator will be 1 by x, and the limit of the denominator is minus cosec x cot x. So that will be equal to limit x tends to 0 plus, so you will get 1 by x minus, this is 1 by sin x into cos, cot cos by sin x. Okay, so that will be equal to limit x tends to 0 plus minus of, so you will get sin x by x into tan x. Okay, now limit x tends to 0 sin x by x, so that is a standard limit. So നിങ്ങൾ പഠിച്ചിട്ടുള്ള limit x tends to 0 plus sin x by x is equal to 1, and limit x tends to 0 plus tan x, tan 0 is 0, so that will be minus 1 into 0, so you will get 0. So the limiting value is 0 in that case. Next is limit x tends to infinity e raised to 3x by x square. So limit x e raised to infinity is infinity, and the denominator name limit infinity varum, so that is an infinity by infinity form. So applying the L'Hospital rule, you will get limit x tends to infinity 3 raised to 3x by x square, so that is 2x. Again you can see that when you look at this limit e raised to 3x by x, so that is again in infinity by infinity form, so you can again apply the L'Hospital rule. So by applying again the L'Hospital rule upon this function, so you get 3 by 2 into again 3 e raised to 3x by 1 varum. Ini limit edukkumbo, so limit will be 9 by 2 into limit of e raised to 3x, again e raised to infinity varum, so the value will be equal to infinity. And next problem is limit x tends to 0 plus 1 minus ln x by e raised to 1 by x. So when you take limit x tends to 0 plus 1 minus ln x, So as x approaches to 0, ln x goes to minus infinity. So you will get 1 plus infinity, so that is again infinity. And so numerator has limit infinity and limit extends to 0 plus e power 1 by x is, so 1 by 0 is infinity, e raised to infinity is again infinity. So this is an infinity by infinity form. So by L'Hospital rule, so you will get limit extends to 0 plus, so when you take the derivative you will get minus 1 by x into e raised to 1 by x in the derivative, e raised to 1 by x into minus 1 by x square by chain rule. So that is limit extends to 0 plus, or you will get 1 by e raised to 1 by x into 1 by x. So that will be limit extends to 0 plus x by e raised to 1 by x. So this will be limit extends to 0 plus x into e raised to minus 1 by x. So the value is equal to be 0. So you will get the limit equal to 0. Now let us look at limit extends to plus infinity x raised to n by e raised to x. So where n is any positive integer. When n is any positive integer, what happens is, this infinity by infinity formula. So you can see that n is positive integer, numerator has infinity, denominator also e raised to infinity is infinity. Okay. Upon L'Hospital rule apply cheyumbo, so what you get is limit extends to infinity, derivative n into x raised to n minus 1 e raised to x. Again this is an infinity by infinity form, so limit extends to infinity, you differentiate again, so n into n minus 1 x raised to n minus 2 by e raised to x. So continuing this way, you will get limit extends to infinity. With the nth derivative, so you will get n into n minus 1, etc. 2 into 1 by e raised to x. So numerator you will have, you will get in the form n factorial by e raised to x. So 1 by limit n factorial by infinity. So something divided by infinity will be 0. So this limit will be equal to 0. And similarly, so let us look at limit extends to infinity, e raised to x by x raised to n, that is again in infinity by infinity form. But derivative e raised to x by L'Hospital rule n into x raised to n minus 1, that will be equal to limit extends to infinity, e raised to x by n into n minus 1 x raised to n minus 2. So continuing this way, you will get limit extends to infinity, e raised to x by n factorial. So when you take the limit, that will be infinity by n factorial, so which is equal to infinity. So those are two limits. So limit extends to infinity, x raised to n by e raised to x is 0, and limit extends to infinity, e raised to x by x raised to n is infinity. So this limit means that, so e raised to x increases rapidly compared to x raised to n as x approaches to infinity. E raised to x in the value bigger value. So this is called as what is called the exponential growth. Exponential growth as x tends to infinity, that is very huge.